Hello and welcome back to Kentucky Home Garage. Today I have 2005 Lexus GX 470 with a 4.7 liter engine. This SUV came in for the brake job, and I looked at the dash and I found the check engine light on, so I took the scan tool and scanned for trouble codes, and I found a couple trouble codes in there. They are in a history basically, and some I have a P1445 secondary air injection system switching valve number 2 bank 2 stuck. I have a P1442 secondary air injection system switching valve number 2 bank 1 stuck closed, and the other ones are for catalytic converter. So I decided to kind of take this opportunity to do some diagnostics for this kind of trouble code, and I'm by no means expert on this. This is the very first one that I've seen. I've done a lot of homework today to learn about it, and it's very confusing when you start to reading the first time. It's kind of there's a terminology kind of was very confusing to me, so I want to explain what is this all about, how it works, and how would I approach this. I'm going to read a circuit description for the system. The secondary air injection system pump air to exhaust port to accelerate the activation of the catalyst. The secondary air injection system consists of electronic control module, air pump, air switching valve like ASV or EASV, air switching valve number 2 ASV NO2 or ASV1-2, pressure sensor, and air injection driver AID. The air switching valve ASV is an electromagnetic type, and air switching valve number 2 is a vacuum type. The secondary air injection system pumps pressurized air to exhaust port by air pump through ASV and ASV NO number 2. Air switch valve assist air switch valve number 2. The air switch valve number 2 also controls air supply. Electronic control module sets signal to air injection driver, and then air injection driver operates the air pump and the air switch valve. The pressure sensor detects pressure and exhaust pulsation in the system when the system operates, and when it does not operate, and sends the data to ECM. Well, good luck figure this out. Alright, so I'm gonna, honestly, I've been on this for an hour or so trying to really understand, because the terminology, this air switching valve repeats itself, and I could not grab all that. It was just so confusing to me. But it basically comes to this. We do have two control modules involved in the system. Alright, we have a main computer engine control module, and we have a AID air injector driver. I did not find the locations of these modules. I apologize for that, but I'll look it up. So the I'm sorry. So computer, the ECM controls one part of the system, and then AID controls other part of the system, which means the main computer sends the signal to AID. The AID controls air pump, the air pump, and controls a air switching valve. And this is what I couldn't understand. There's two valves, and I'm gonna go to this diagram, make it a little bit, hopefully a little bit easier. Now, the problem with this most of this stuff is basically underneath the intake manifold. You can't see anything. But the way that so you have an air pump that's controlled by the AID. All right. Now, for air to go from the pump into the exhaust manifold has to pass all these valves basically. So when the engine control module sends the signal to IAD to activate the air pump, it's going to give the power to the air pump, and also is going to give a power to air switch valve, the first one basically, that is getting the air from the air pump. Now, other two valves, they are vacuum controlled, and the control ECM controls the vacuum solenoids that's going to apply the vacuum to these valves, and these valves are basically divert valves. They will send the air to bank 1 or bank 2 exhaust manifold. So that's the way it works. Also, the air injection driver takes a information from feedback from pressure sensor. Pressure sensor is also down underneath the manifold, and reads the signal from the pressure sensor and sends that signal to engine control module. It is really messed up. I mean, it's just so many air valves that I could not figure out what is what anymore. So basically it comes to this. You have the, let me actually, you have the air pump that is underneath the intake manifold. You have this air switch valve, the first one, I call that number 1. So that air, this valve is going to take all of the air from the air pump. Okay, it's going to open up the passageway for all that air to go to the second valve, which is operated by vacuum. Those other two valves are called number 2. There's one for bank 1 and then one for bank 2, and that's basically going to split the air into 2 exhaust manifolds. In a wiring diagram, we have some relays. We got a whole bunch of fuses involved as well. So now we have a, I'm going to go to ECM. ECM controls the EFI relay. As soon as I turn the key on, it's going to energize the EFI relay. EFI relay is, the control side of the EFI relay is grounded all the time, so the ECM is going to send 12 volt to energize the relay. Once the relay is closed, now the relay gets the power from fuse, EFI fuse. I'm going to show you that as well. EFI fuse, it goes to load side of the relay. Once the relay is closed, then it's going to give the power to another fuse, the EFI1 number 2, and then it's going to take all that power to a 2 solenoids who basically is going to control the vacuum for number 2 valves, air valves. So now we know that these solenoids are a ground size switch because they got a power. Now the computer is going to control them by giving a ground to these 2 solenoids. Once now the solenoid is there, they are connected to the vacuum source, and once they open, they're going to send that vacuum to a air valve 2 to get open. Now, air injection driver, once it gets a command from the main computer, the ECM, to activate a air pump is grounded. The AID is going to send 12 volt to air pump. We have also there's a big fuse. It's a 50 amp fuse. It's in a fuse box. It goes through the module and then it goes down to fuel pump. And also, IAD is going to energize the air switch valve number 1. It's one that's right next to the air pump, and Basically that's the way it works. So now, unfortunately, most of the components involved in a system are underneath the intake manifold. However, in our code, we have a problem with air valve number 2 on both bank 1 and bank 2. So basically they are stuck closed or stuck open. I don't know, they just says they're stuck. So I want to, now this scan tool has some bidirectional controls, and unfortunately only gives me 5 seconds that I can look at the data, and that's it. After the 5 seconds it's going to shut down, and then I have to wait 30 seconds and it will do it again. So I saved some data in here, and I'm going to explain that later. What to look for in your data that kind of gives you a direction which way to go. So in this scan tool, I'm really having a hard time with this camera to focus my scan tool, but basically I'm gonna go to active test, and I'm going to activation the VSV for secondary air control. Okay, now this I'm going to do a custom list. I'm just going to pick some data. The good thing about this test, it's going to activate every single electronic device involved in this system. So it's going to activate our air pump, it's going to activate the solenoids for our air valve number 2, so that our solenoids send the vacuum. It's going to activate our first air valve, and now it's going to give us some data. Also, what I want to look at my oxygen sensors on bank 1 and bank 2 pre and post cat. I want to see reaction once I activate the system. If I have air entering my exhaust, those numbers, my oxygen sensor will read lean. They're gonna see air coming, oxygen coming into the exhaust. Now, this is only possible to do if you have good oxygen sensors. If your oxygen sensors don't work, this is not going to help much at all. However, the pre-cat sensors on this, it's air fuel ratio sensor, the wideband sensor, the downstream, it's regular O2 sensor, basically go from 100 millivolts to 900 millivolts. The air fuel ratio sensors, if everything goes okay, 3.3 volts it's normal. Anything above 3 point, it's lean. Anything below, it's rich. So now I'm going to pick my my data, and we're going to do the test real quick. But again, it's not going to give me much, because it only takes 5 seconds of the okay, just give me one. I'm working. I'm sorry, guys. Okay, there's one. So oxygen sensor, bank 1, sensor 2, bank 2, sensor 2. I'm going to take the lambda reading. I'm going to take my air fuel ratio sensors as well on the bank 1 and bank 2, and other PI, we can also look at the, this is actually very useful, our pressure sensor, the pressure reading from the sensor. And now, okay, so now I have a air pressure reading. You got 14.2 psi, which is normal. My air fuel sensor is a 3.3. That's should be. Lambda is 1. The engine is not running, but it'll be. You'll guys see what's going on. And also my downstreams are at 1 millivolt. Now I'll have to wait a little bit. I'm going to start the car. I have to wait for my downstream sensors to warm up a little bit. I don't want to make this video too long, but I just there's so many components involved in this system that it's just it really takes time to explain everything that I would like to explain. So I'm still waiting for my my downstream sensors to warm up. Takes a couple of minutes. So right now you guys can see my let me. Okay, so we see that our lambda is 0.9, it's 1, it's actually, that's where it needs to be. So and the lambda, so anything above the 1 is lean, anything below 1 is rich, and 3.2 and 3.29, that's our air fuel ratio. So everything is working okay. I'm still waiting for my my downstream oxygen sensors to warm up, and the reason I want to see this. Once we energize our solenoid, all these numbers are going to go down to 100 millivolts because it's going to add so much air in the air system. So this test is going to give us some ideas. If we have a flow of air, very important also is air pump pressure. Okay, so 14.2. Now, if you see your air pressure extremely high once you energize this, maybe 18 or 19 psi, that's a clear indication that you have a obstruction somewhere. So the pump is running, but the air has no way to go. So here we go. Now we can see our downstream sensors are warming up, and there's going to be a couple more minutes, and we're going to activate the system. And I think this should be okay. Now I see these numbers. Sorry. my downstream oxygen sensor should go lean. Now you can hear our pump is running. My sensors are lean. Okay. So. Alright, so let me shut it off and then okay, so we could see that all of our sensors, the downstream oxygen sensors, went down lean. Okay, now that gives an indication that we have airflow through our exhaust manifold. For you guys who have a gas analyzer, you can do that also. You can put a gas analyzer in the tailpipe, activate the system, and then you should see that your oxygen should go skyrocketing. So because you got so much fresh air going through exhaust manifold. So it seems like this is a history code, but so far seemed to me that everything is working the way it should. Now I've done some playing with this, and again the problem is this takes 5 seconds and I can't really explain what is happening. So I did some homework, and let me see here. Okay, So I need to move my camera now, and I'm going to talk about a little bit of the I think this is, you guys are going to benefit from this. So this is a saved data. This is not a live data. So I recorded this earlier today for this purpose, to make the video. Okay, so let's see. All right, cool. So this is how the normal system looks. Okay, again, this is a history code. I don't see anything wrong with it, but this is what we look for. So I choose a engine speed. RPM, it's not relevant, but just for, I just did it. So we can see that's a 1300 RPM. Now this is very important, our downstream oxygen sensors. This is the moment when our valve is on. Okay, so you have air going through your exhaust manifolds. So engine speed is 1300. My downstream oxygen sensor, both of them went lean. So right there tells me that I have airflow. Okay. Now my air fuel sensors on bank 1 and bank 2, 4.9, maximum voltage, so super lean. Another indication, I have airflow. My lambda, 1 is normal. Anything above the normal, I'm sorry guys, anything above 1, it's lean. 1.23, 1.23, super lean. So again, I have plenty of air in my exhaust. Air pressure, it was 14 psi. When I activate the pump, went up to 15 psi. So there's going to be some resistance from the air to go through all the passage waves, but when you activate your pump, this is okay. 15.4, that is your normal reading. Okay. Also, for you guys who have a M clamp, if you want to play with the M clamp, I could not, because it's not really easy to find the wire for air pump, but you could put an M clamp around. Actually, it would be really nice to know what is a normal amp draw. If you see higher amperage, that is another indication that you may have an air pump problem, but also you may have an exhaust in the air, where the air is pushing, the pump is pushing the air, but because of the restriction, it has to work harder. Now my next one, let's see, for a second, okay. What I did in this one, I had completely obstruct the system, and what I actually did, these number 2 valves, okay, they are vacuum controlled. So I actually unplug my vacuum source. I activate the system, so the pump is running, the first valve, air valve is open, but the second valve is supposed to, the divert valves are, because of the lack of the vacuum source, they were remaining shut. So the first red flag for you guys, it's air pressure, 18 psi. Okay, this is the first, I'm sorry. First red flag, 18 psi. The system is completely shut, pump is pushing the air pressure is rising because it's got nowhere to go. All right. My upstream sensors, they stay the same, 3.3, you can see. So no changes in my sensors. My lambda stay the same, around 1, so there is no extra air to mix with our oxygen, our fuel ratio sensors. The downstream, I'm a little confused about downstream. I really don't have an explanation for it. They went lean for some reason. Maybe they were more, I don't know. I can't understand why the downstream went lean, but upstream they're normal. So, but nevertheless, look for your pressure on your air pump. This is your first clue. And upstream, so that both of them are the same. Now, on my next capture, what I did, I cut the air vacuum supply to only one valve, which means one valve is going to deliver the air to exhaust, but another valve is shut, and I'm not sure if we'll see it's bank 1 or bank 2. I'm not sure. Let's see here now. It is first. Let's see, I need to find my okay. This is my capture where I only obstruct one side, and this is actually pretty cool, guys. My air pressure is 15.7, almost the same as a normal one, because there is a airflow through that through the exhaust. However, when we see this reading here, our bank 1 downstream is lean, okay, which means it was not obstructed. I'm sorry. Bank 2 sensor 2 reads rich, okay. There's a red flag right there. This is your side that's obstructed. Now, air fuel ratio sensor, bank 1, sensor 1 went lean. Yep, went lean, and then which correspond with my bank 1 downstream sensor. So bank 1 is lean downstream, and bank 1 is lean upstream. So we got a 5 volts. Down the bank 2, we got rich because we don't have an extra air in the system, and upstream bank 2 is stayed normal because it has no, it did not read any extra air. Okay, I really hope that this makes sense. Okay, so I hope, again, I couldn't do this live because just the 5 seconds it's not enough, and this tool really I cannot capture the live data on it. I can, but not in this mode. I could only take a single picture of it, of the event. So that's the best I could do. But you guys could see. So my point is this: if you see high pressure on your air pump, that's the #1 indication that both of your could be obstruction on your air valve. Okay, could be the #1 right next to the air pump, or could be both of the second air valves, the valve controlled. If you see where one side is lean and the other side stay, one bank is lean, another bank is it's normal or rich, you have obstruction on. I mean, yes, that's right. So if you see the lean, I'm sorry guys, if you see signal from your O2 sensor on bank 1, for instance, go down to lean, that is your good side. So that means the air is flowing through that exhaust manifold. If your bank 2 stay the same or go rich, that is your obstruction right there. So now I'm going to do the rest of the test on top of the engine. I want to show you guys what can be done on top of the engine before we get underneath the intake manifold, or do we really need to go into the intake manifold in the first place? Do we have a problem, electrical problem on top of it, or do we have to go underneath the intake? So let me get this scan tool out of here, and some water, sorry. Okay. So now I want to talk about what do we see on top of the engine. Maybe I should move the camera on the other side actually. Alright, that's better. I like it. Okay. Alright, so right in here are two solenoids that are controlled by our main computer engine control module, and they will send a, once they energize, they will send vacuum to a number 2 valves, one for bank 1, one for bank 2. They're going to get open and let the air out. Okay, so before I forget, what you guys can do, you can unplug this solenoid and you can measure resistance. I checked it, it's supposed to be 40 ohms. So you can check both of these solenoids and make sure they have a 40 ohms of resistance in it. Now on our on the wiring diagram, we have a these are two solenoids I will just show you guys. So we have a white wire that is going to through our EFI relay. That computer is going to energize the EFI relay. The EFI relay is going to take the power from EFI. I'm sorry. Oh my God! I'm sorry, guys. Sometimes I just have a brain fart and I can't. It will take the power from the EFI fuse. It will go through relay. It will give power to EFI number 1, number NO2, number 2 fuses. So there's a second fuse, and then it will give the power to both of these relays on a white wire. Now the computer controls these two relays by giving the ground on one it's red wire, on another one is gray wire. So now we can do a couple tests. We can check for the power on both of these fuses. I mean solenoids. I'm going to use a test light. So I'm going to unplug. I know this is not the favorite way of doing, but you can back probe a solenoid or use a voltmeter. I mean, either way it's okay. So unplug your solenoid and just lightly touch. I'm going to check my test light real quick. Alright, it's good. So just touch this solenoid. Don't jam in your connector. So let me see. So I'm going to touching my oh, you know what? I got my key off. Just a second, guys. I got to turn the key on because my relay is not. Now this is, there you go. You don't have power, so now you have to figure out why you don't have power on it. All right. So as long as we have a key on, our relay will stay energized. So now we're going to check the power to our. Now we can see our lights. So I'm just lightly touching this. I'm not jamming this in a connector. Now I will also check the power on the second solenoid. There you go. And there you go. We have a. Okay. Now we know we have power. If we do not have a power, we have to check some fuses in our fuse box, and also we have to check the relay. I'll take you guys to show you what the fuses are. I'll take my camera off the tripod real quick. So here's the fuse box. This relay here is the relay for your solenoids. this 50 amp fuse, the big one, that is a fuse for your air pump. It's very important. If your air pump doesn't work, you have to check this fuse. There's one fuse here, number 1. There's one fuse, and then another fuse is right in here, right next to this relay. So they'll check both of these fuses. Make sure if you don't see the power, if you don't see the power on your solenoids, we need to check these fuses in the relay. Now, if you have a relay problem, that's a little bit more complicated. I mean, there's so many videos how to check the relays, but this one is working okay, so I really cannot spend the time on that. Okay, so my next test, what I want to do, I want to make sure that my solenoids are working the way they should. And let's see if I can get a little closer. Alright, so we have a this hose here is a main source for your vacuum. It comes from intake manifold. Let me take the camera off again. So, like for my code, where it tells me that I have a problem with the number 2 valves. So this is the first you want to check. Make sure you have the vacuum on this valve. Now you can see that vacuum goes through this hose. And then gives the this is the supply for this solenoid, and this is a supply for this one. And now these 2 hoses are actually supplied to valves. They live down underneath the intake manifold. Now I'm going to do some checks. What I'm going to do, I'm going to energize each of these solenoids. I'm going to start the car. I want to have vacuum in my lines, and I'm going to do some checks with the vacuum line. What I'm going to do, I'm going to back probe, since I have a power on this white wire here. I'm having a power in this white. I'm going to put my test light to ground. I'm going to connect my test light to ground. I'm going to T-pin this portion of my connector, and I'm going to energize my solenoid. Now, guys, if you don't feel comfortable doing this, you can unplug it and get some extension some jumper cables. Actually, I got some. And you can energize solenoid by giving power and ground to it. So if you don't feel comfortable doing this, this is the what I made, like something like this. It's a very small connector, and now I can easily just go down and plug it into my solenoid. Like that. So and I need another one to put in. I'm sorry, this is actually, it's not plugged in yet. There you go. So now this is a power, this is a ground. It's not really matter if you have this unplugged. You can do it away now. So if you don't feel comfortable doing this test, don't do it. Just unplug your solenoids and get these connectors and little bit of wire, just solder some stuff together, and you can make nice wires. So then you can energize it that way. So okay, so now what I want to do next, I want to make sure that my solenoids are working correctly, and I want to check for I'm going to use a vacuum gauge. So the first test, I'm going to check my supply. Okay, so I'm gonna unplug this hose. Okay, I can actually feel the... So I'm just gonna get my vacuum gauge. I'm gonna start the car and I'm gonna look for vacuum on my gauge, make sure that my main supply of vacuum is there. Okay, once I do that, then I'm going to get this same gauge and I'm going to put on each of these solenoids. I'm going to energize the solenoids and I want to see the vacuum coming from... I'm going to put this back on and I want to see the vacuum going through solenoid to my gauge. So I'm going to get the jumper wires, and so I'm back probing the red wire on this solenoid. And your test light is enough to, it has enough current to energize the solenoids, so you don't have to have jumper cables or anything like that. Now I'm going to back probe my red wire. Okay, and actually I can touch it right now. We should hear our solenoid clicking. There you go. Okay. Alright, so now, so the first test basically is going to be just the main vacuum supply to my solenoids, and then we're gonna put our hose back on this tube, and then we're gonna check each solenoid for proper gosh, I got my... So basically we're going to check each solenoid if they're working properly, if they're delivering our vacuum from our source down to our switching valves. So let me start the truck, I'll be right back. Okay, so now we can see we have plenty of vacuum for, vacuum source is good, so I'm going to unplug the vacuum source and I'm going to plug it to my solenoid rail. So now next, what I'm going to do, I'm going to unplug my hose on this, in the first solenoid. So this is the one that goes down to our control valve, our switch valve. Let's see. Let me just check my camera, make sure. Let's see this. Okay. I'm going to take my vacuum hose, vacuum gauge. I'm going to unplug this hose. Alright, so now I'm going to energize my solenoid by providing a ground, and I should see a steady vacuum there. There you go. Okay, so this one is good. And then the same on the second solenoid. So now this one, I'm going to back through the green wire. So let's see if this one works. So some roll under the... There you go. So now I know that my solenoids, both of them are okay. They both have a good vacuum supply. they are able to open and send the vacuum supply down to our switching valves. One more test I want to do with the vacuum. I'll show you guys in a second. I have another one with this T adapter. What I'm going to do, I'm going to connect one end to my solenoid, and I'm going to connect another end to my hose that goes down the valve. Now when I energize this solenoid, if I have any problem with my valve, if my valve does not, because it's a vacuum controlled, if my diaphragm is bad, then this should give me a clue. If I cannot hold the vacuum now, I might have a bad diaphragm on my valve. Excuse me. There you go. Looking good. Let's see a little bit better. So. Now this tells me that this valve can hold the vacuum. I'm going to do the same one on the other one, the same test. There you go. Let that open. I think what I have a problem is this test light doesn't have enough current sometimes, and it'll. There you go. Now we can see it holds the vacuum. So now I know my second divert valve is good as well. So it holds the vacuum. Everything is okay. So now this test doesn't. If you don't have a bidirectional control, you know, when you energize a solenoid like this, you still don't know if your driver is able to energize the solenoid, but at least to do that you got to have a scan through the bidirectional controls. Or do this very test at the very first start when the engine is cold, when the computer energizes all these solenoids. All right. Okay guys, so I think this is pretty much all we can do on, you know, to get some clues, to get some information, you know, what is going on, and if all this checks out okay and you still have a problem, then you know, you need to go down. You need to take your intake manifold and inspect your air pump and other valves. One thing you can do to I got some pictures here. Like this is your let's see, divert valve, or the valve number 2, one that's vacuum controlled. So this is this is where your vacuum goes in, and this is where the air comes in, and that's where it comes out. Now what you can do, once you get there, take your valves out, and you can take the air, shop air, apply the air pressure to this end without vacuum. Apply the air, and the air should not leak out. Okay, if the valve is good. Now, if that's okay, then you're gonna get your vacuum pump, apply some vacuum in here, and then apply air again, and then you should have a flow of air through your valve. So that's the way you can. That's the only way actually to test the vacuum controlled valve. Now the valve number 1, that's electronically controlled. We can, once we take everything out. So this is the so basically we can use the same test, but this is our intake. This is where the air comes in from the pump, and this is where the air comes out. So we can take the air, shop air again, apply some air without energizing this, and the air should not escape. So that tells you that the valve is closed properly. Now then we can use some jumper wires, put power and ground, energize this solenoid, and do the same test. Let the apply some air, and at that time you should have a passage. The air should flow from this side from inlet to outlet. So that tells you that your valve is actually functioning the way it should. And so that's that. If you have a problem with the pressure sensor, pretty much before you get to sensor, all of the tests will have to be done at the computer itself. You'll have to do all the measurements at the computer. And so I mean, what I wanted to guys show today is what to look for on the scan tool, what to test, like especially in my code, in my case where I had a code for my air valve number 2 both being stuck. So I can check my solenoids, I can check my vacuum supply, I can do all that kind of stuff. Also, of course, with my scan tool, I could look at the voltage and all that. When I energize, the whole system is going to energize my solenoids as well to make sure my computer is able to do it. I didn't have to do it at this time because when I looked my data, everything looks normal. So this is intermittent problem. So at this point, I'm not gonna change any parts, because honestly, I don't even know why the computer flagged the code. Maybe I don't know. So maybe we just have to wait and see what happens in the future. So okay, guys, I think this is all I wanted to talk about with this particular vehicle. I hope you guys enjoy this video. Again, I didn't want to make it too long, but there's just so many steps and so many components involved in this. I think it's worth to watch this video to get some guidelines how to approach this problem. So guys, thank you so much. Please put some subscribe to my channel. Give me some hints, what I need to improve, what would you guys like to see. I'm not professional by no means. I'm home mechanic, as you guys know. It's a Kentucky Home Garage. I don't do this for a living, but I do enjoy diagnosing these type of problems. And I think this is all I wanted to present at this time. Again, thank you so much for watching, and please subscribe to my channel, and see you next time, guys. Thank you so much.